Hi, my name is Joshua and this is my artifact for CT4 Toga. For this game, I wanted to create a gacha-like dungeon crawler which mainly focuses on RNG and item dropping, like that of the game Genshin Impact MiHoYo 2020, only text-based. By using RNG, I was able to create features such as crit rates, enemy spawns, and equipment rolling systems. This system takes keys that drop from enemies and uses them to create a percentage-based chance of the player obtaining different rarity level equipment. These new items can then be used by the player, increasing their stats and making it easier to fight the higher level bosses. Ultimately, this creates a cycle where the player keeps fighting enemies on their skill range and then using the key drops as a way to get stronger, enabling them to eventually defeat the final boss, but only if they're lucky with their drops. When writing my code, I made sure to use techniques that would make it as efficient as possible. This prevented repetition of code and cluttering of the program, making it easier to read and change where needed. With the logic aspect of my program, I'd already done some research using C++ for Dummies, R. Davis 2014, so I knew that functions, quote, reduce the complexity of creating a working program of significant size to something achievable. I used functions within functions using passing by reference to create a lot of the game logic that would be used on a regular basis. This was apparent in the boss battle function, as I knew I was going to have 7 individual bosses. I decided I was going to create one function with lots of separate functions inside, making up one fight sequence. This would run a sequence for whichever enemy objects will pass through the parameter, allowing both the player and the enemy objects to defeat each other. This made my code very efficient by using functions to declutter the program and also save a lot of time. It also enables me to add more enemies to the game due to its reusability, adding modularity. A drawback I had when creating complex functions such as the drop system was trying to manage the functions within the functions. I found the 11 parameters I had to pass through hard to manage, as I had to figure out if the function that was calling the smaller function had those parameters I needed passed through to it. In order to improve this in future projects, I need to use commenting in my code a lot more whilst actually programming the game. This would have given me more indication on what functions needed which parameters. With regards to data, I carried out some research on a forum called Why Are Classes Useful 2005, which stated that classes, quote, take all the properties and behaviours of an object in your program and combine them into a single interface, then reuse that interface wherever you need that type of object in your program, ultimately making your code efficient through reusability. I use classes to group similar variables together, for example the stats for the characters, enemies, weapons and equipment. This made my code more efficient as the classes could be used to create objects, preventing me from having to declare and define 100 plus variables, which would create clutter and make the program harder to read and change. For future improvement, I'd like to learn in greater detail how and where to use inheritance, especially in the type of game I was making. I feel I could have made my classing system even more efficient by grouping all of the enemies, heroes and player classes under one parent class called entity. This would hold variables such as the stats and names without having to rewrite those classes within each class, increasing readability and efficiency. With problem solving, I had issues involving both syntax and logical errors, which took me a considerable amount of time to figure out using different problem solving techniques. When making multiple armor objects, I created one first and then copied and pasted it as many times as I needed. I then changed the object name and stats for each new object and tested my game to make sure the player could get every piece of armor. The issue occurred when, on a 3-star rarity pool, the player would only be able to obtain 2 of the 3 available armors. I initially thought the issue arose from the weapon drop function, as was a result of the random function having too low a range. I increased this by 1 but it still wasn't giving me the item. However, this wasn't the case and in fact was caused by a syntax error from when I copied and pasted over the objects, not realising I hadn't changed over the object parameters passed for Zafkiel, meaning that every time I pulled Zafkiel I'd get the Devil's Fruit, making Zafkiel unobtainable. I resolved this issue by rubber duck debugging, explaining the issue out loud, enabling me to focus on what I was saying, making it easier to find the problem. To improve in the future, I'd use this method earlier, as I could have saved a lot of time by not having to search through individual functions, changing their parameters and retesting the game. The second issue I had was in regards to the game logic, specifically the function to check what room the player was in. Essentially, I'd created a system which used a nested loop in the player's position to figure out what room they were in by comparing the iterations of the loops to the player's coordinates, and then returning that room number to the source file so that corresponding functions could start running. When creating this, I had an issue where the X and Y axis were being swapped, so when the player moved one space to the right they would move to room 7, however if they moved down they would be in room 2. So I needed to figure out why these axes were inverted. I drew a visual representation of what I was trying to achieve so I could look at the whole issue at once, allowing me to see why the problem was occurring. Whilst it looks confusing, this helped a lot, as I was able to work out that I had to swap over the A and B variables. The function was comparing the player X position to the Y axis of the map and the player's Y position to the X axis of the map. This meant the function would run through iterations of the first column before moving to the next one, when what I wanted was for the rows to be iterated first, then for it to move down to the rows underneath. To improve my fault finding ability with this, I could have changed the variable name for A and B to something more relevant to what they were used for example x-axis and y-axis. As the fact these had no correlation with the player x and y coordinates in terms of variable names caused me to become confused when trying to work out the issue. Overall, I feel my fault finding could have been improved over every issue if I used techniques like the ones I did but only sooner, as opposed to looking through the lines of functions and code trying to work it all out in my head, as this became overwhelming and hard to figure out. When it came down to professionalism of my program, I covered the following areas. For reusability, I first researched what made code reusable. I found an ebook called Learn Computer Programming, Writing Computer Programs, which explains how, quote, functions provide better modularity for your application and a high degree of reusing. I made sure to take great advantage of functions and classes to allow aspects of my code, such as the boss fight drop system and roll system, to be called and used anywhere in the game, where different data from the classes will be passed through these to change the outcome. This is important, especially in the creation of a game, as by taking reusability of code into mind when designing the program, you cut down a lot of repetition of code and also add a lot of modularity to the software. This is useful as it creates time efficiency and declutters your code, making it easier to read and adapt. I specifically chose to design my functions for reusability, as I knew that my game would have multiple sequences it needed to repeat, such as the fight sequence. Any of these functions could be called from anywhere in the program, running the game logic but with the potential of different outcomes depending on the parameters I passed through. This made the code in my game very reusable. To improve my reusability, I'd like to make a more efficient version of the item drop function. This worked well and was more efficient than writing logic without functions. However, each chest is a separate function that follows the same logic, minus the transfer of data from the item that you've just obtained to the item you already have equipped. I feel there would have been a much more efficient way of writing this using only one function that encapsulates all three chests and then uses a conditional statement to declare the parameters that will be passed through to the one function. In regards to my layout, I made sure to split my program up efficiently into separate CPP and header files. I have a CPP file for my source code, which I've tried to keep as clutter-free as possible, primarily only using one gameplay loop and functions, as well as a header file which holds my class and function declarations. The last two CPP files hold the function definitions and the class constructors. By having the program in this layout split into different files, I'm using good practice to make my program user-friendly and easy to adapt. To improve my layout, I'd like to divide these files even further, creating multiple and more specific function files, storing logic which is similar or used within each other together to make the program even easier to read and adapt. Before creating a consistent style, I researched what a professional standard was. A document called C++ Best Practices, Turner, gave me great insight on creating a professional consistent style. I needed to use, quote, naming conventions, specifically, quote, functions and variables that start with lowercase, quote, comment blocks, and to keep, quote, lines of reasonable length. You can see this followed throughout my program, and how doing this research has improved my naming conventions, making them follow a consistent style of camel case. In terms of user friendliness, I used a variety of methods to make my program easy to read and give a grasp of each line's purpose. I use line commenting to allow me to write notes on what each line does in basic English. On top of this, I use indentation to show what logic was contained within conditional statements. I personally find this very useful within this game, as I sometimes have to use conditional statements within other conditional statements, so by having indentations I could clearly identify which logic was applied to which conditional statement. Finally, I made sure not to abbreviate my function names, as this gives the user a basic idea of what each function does and makes it easier to remember when calling the function. These are all really efficient methods of making my code user-friendly, converting the C++ language into basic English, and using visual indents to make the structure and logic of the software clearer to anyone who looks at it. On reflection of my performance during the Toga module and the artifact, I feel I've worked hard to learn a lot about programming in C++, not just about how to create programs, but why and where you would use specific methods and techniques to achieve an outcome. In turn, this helped me create an ambitious text-based gacha-like game that I spent around 200 hours making. I used a lot of techniques and methods that are used in professional games to replicate attributes of the gameplay from this genre, such as RNG and item dropping. However, a personal development is learning to be patient when studying the subject, as I need to realise that I'm not going to understand everything instantly, and I need to persevere with topics I don't understand, instead of becoming frustrated and not adapting to absorb knowledge. I feel I could have implemented more use of the advanced topics such as inheritance, STL and pointers if I'd been more patient when studying, further improving my skills and artifact. To look at ways to improving my learning skills in the future, I read a journal article called Effective Learning Strategies Making Knowledge Stick, Lombarda 2020, which explains strategies for effective learning. I feel the quote drawing method, which explained how you can quote turn descriptions into simple images that represent the ideas, would be the most effective for me, as I'm a visual learner and I find it a lot easier to understand something if I can see it through an image.